Hi there! This fantastic device sitting next to me is a Typesetter Keyboard. Now these, I did a little bit of research on Wikipedia, and these were used to operate something called a slugcaster. A slugcaster is some form of printing press, a linotype, that would have been used by newspapers and such back in the day to produce their printed material. And what they realized that it was better to kind of divide the behavior up, so that rather than someone operating the slugcaster directly, you would have these units where people could type in the material and produce the input to the slugcaster separately. So maybe you could have several of these people and several people entering copy all at the same time. You'd put your printed material in here, you'd type it in here, and out here would come punched paper tape that you would feed into the slugcaster machine to produce your printed material. So one thing about this device, it has no I/O ports on it anywhere. There's no serial port, there's no parallel port, there's no communication whatsoever on this. This is totally sneaker net. You type in here, and out comes the tape. You cut off the tape, you take it and you feed the tape into your slugcaster machine. Let's just crank it up, and people can see an example. So yeah, here, let me advance it a little bit. So there, you can see out here it printed. Hold it up. Printed here in kind of a 6-bit code, the various characters that I was typing on the keyboard. It is a 6-bit device compared to the 8-bit computer devices that you might have for 8-bit programs going to punch tape. This was only 6-bit. So, I mean, you can see the thing is very loud, noisy. I don't know how people dealt with this back in the day. Maybe you wore earplugs while working on it. But you've got no visual display. You're just blindly typing into it, and your output is coming out here in this tape, and then the tape you take it to the other guy who runs it through his slugcaster machine. And the reason I bought this is because I wanted to start working on paper tapes for my vintage computer. So maybe my RC 2014, maybe my Heathkit H8. Now I can figure out how to DIY a paper tape reader. That's not hard at all. People have done that. There's projects online. I might just adopt one of those projects. But to actually do a paper tape puncher, every time I've just sat down and tried to figure this out, it's turned out to be like a lot of complicated work that would have me trying to do milling and machining and stuff to make a punch machine. Now ideally I would get something like a Heathkit H10. I would love to have a Heathkit H10. No resources for finding a Heathkit H10 have been forthcoming. Maybe someone will just drop one in the mail and send it to me. That'd be wonderful, but I'm not counting on that happening. So I started looking, what can I find for other vintage teletype type equipment? And I found this contraption on eBay, a couple $100, and appeared to have what looked like an industrial quality, commercial quality punch mechanism. Now, true to eBay, it didn't work. Shocking. Well, the seller actually did disclose that, said in the listing, hey, I couldn't get it to punch, and I figured, why not? I'll see if I can fix it. And I did fix it, as you just saw. So now let's go walk a little bit back in time, and we'll talk about what I did to repair this thing, and then we'll talk about how I'm going to automate it so that I can hook it up to a computer, and then we'll talk about how I'm going to get it to output 8-bit instead of 6-bit. Okay, let's take a quick look inside. To get inside, we just have to take 4 screws loose from the top, and then we can lift the top off. And we can see inside the unit. Okay, this should give people a really good view of the inside. We're now looking at it backwards. The keyboard is over here. You can see the display board here. It's basically just some LEDs and switches. And then we have this cable here is coming up from the power supply. And this cable here is going over to the paper punch unit. The paper punch unit is here. It's got this big motor. This is a big motor that runs all the time. And then there are lots of solenoids. I'll have to maybe get another angle to see the solenoids on there, but I think that's what the majority of these wires are going over to there, to the solenoid. There's actually 4 of them mounted on the top. There's more of them, I think, that come up from the bottom. Okay, let me get a few looks at the paper tape punch mechanism itself. So here we are kind of looking at it from the back. Let me pan around the side. kind of see in there. We can see some of the solenoids on top and on bottom, and you know, it's like this weird coil here, and I don't know what this does because there's nothing that comes up to it. This other one down here is he's kind of by this timing wheel, and I don't see anything that he could pull on, this solenoid down in there. But maybe somehow he's doing sensing. You know, maybe he's sensing this wheel and can tell as that wheel turns around. I'm not sure. I'd love to know what kind of mechanism, who makes this mechanism, and whether there's data on the mechanism itself. I'm assuming it's just some kind of a standard teletype paper printer mechanism that you would have found in other equipment. There's another view here. Look down in there. Down there with the motor. And let's come around and look kind of from the front. See here, this little door opens up. There's this sprocket in here. That's the sprocket that moves the tape along. Then we've got all of these punches, and we can see that it is set up for 6 bits. So there's 6 of the big round ones, the little index one. But there does look to be 2 additional punches over there that are clearly not used because there's no paper in them. So we'll see. I'll be curious to see if those have solenoids, if we can fire those up, and we can turn this into an 8-bit punch. So the problem with the device not working turned out to all be in the power supply board back here. And my clue that there was a power supply problem is I looked on the logic board to some 74 series TTL logic, and they were only getting about 3 volts on my multimeter. And I think if I put the scope on it, you'd have even seen that it was probably oscillating due to bad filter capacitors. So this power supply had a couple of big filter capacitors in here, like there and there. Just these old things. I pulled them, I checked them on my tester, and they're dead. You know, they were completely dead. So I recapped it using the best I had. We actually did have a 6800 microfarad that was acceptable here, but I did not have any 3300 microfarad 40 volt rated caps. But I did have a total of 4 3300 microfarad 25 volt caps, so I put them in a series parallel configuration. So 2 of them hooked in parallel here to double the capacitance, another 2 in parallel over there. And then you put them in series, which will double the voltage and have the capacitance. So you ended up with 3300 volt or 3300 microfarad 50 volt equivalent there. And that'll suffice until the decent capacitors arrive from the supplier. So I'll replace it with the right one eventually. And then the parts showed up before I was done filming, so I went ahead and I recapped it the right way. So we've got nice new capacitors instead of the conglomeration of 4 of these guys. I've got the right one. I also replaced a little 1000 microfarad at the end. Okay, here's the logic board. Now I spent a lot of time going through this, trying to reverse engineer it, a lot more time than I had expected to spend on it. I didn't fully reverse engineer it. I kind of got tired of tracing schematics and paths and such on this board. So I stopped a little bit short when I've got as far as I believe I need to get. Over here are the connectors for the punch itself. So there's one here which I believe has all of the wires for the solenoids that punch the individual up to 8 holes. 2 of them are unpopulated, so this is a 6-bit device. It does not do all 8 of the holes. The punch seems to have all 8 solenoids, but 2 of the wires just terminate here. They don't go to transistors. There's also a sense that comes in from the punch so that it can do like an RPM sense and know where it is in the process of spinning. There's another connector down here which is mostly unpopulated, and this one I believe has the directional control solenoid. So there's 2 solenoids that operate cams that will make the tape feeder go forward and backward. This big connector here is for the power coming in. About 27 volts for the solenoid. There's minus 12 volts probably needed by some kind of ancient logic chips in here. And there's plus 5 that runs almost everything else on the board. Over here we have the solenoid drivers. These are all MJE 800s. There are a total of 9 of them. 6 of them for the data bits. 1 of them for the index hole. So there's the hole that is used to be driven by the sprocket. That's kind of a little smaller hole. So that gets you 7. plus 2 for the directional, the forward and reverse. You've got a couple up here hex inverters, which are the drivers for this. And that's where it starts to get weird. Over here are a couple of 4x4 register files. I've actually used those very similar chips in a lot of my Z80 projects for doing memory paging. There's something where you can write bits in and read them independently. Those two register files hold 8 bits. Go to this set of pull-ups, so they're open collector output. Go to these pull-ups, and then feed the driver transistors. So I thought, okay, everything's going to be simple. If I want to drive this from a Raspberry Pi or something, I'll just start shoving, signals onto this resistor pack here. It's open collector. I can just start pulling things down, and I'll be able to make punch go. Well, it did not work out that way at all, because somewhere on here, over here, are a couple of 74 193 16 to 1 clock dividers, or some weird thing. 2 of those together, it forms an 8-bit counter, and that 8-bit counter populates those register files. So when this thing is normally just sitting here and you're not pushing a key, it's continuously pumping new values into the register files, which are going out here and going to the solenoid driver. Now, it won't actually fire the solenoids based on that 8-bit counter that's going on there. It needs another signal to make it actually do a solenoid sequence. But it's just weird. There's just like free running here 8-bit counter. And I think the way they did it is they took that 8-bit counter and they ran it down this connector to the keyboard. And that it just scans 256 values out to the keyboard. And then the keyboard, when you actually have a key down, maybe it punches something up here that says, okay, I pushed a key. And then at that point, it will increment the position in the register file. So the register file, I think, could be a 4-key buffer. It's 4x4 register file, so you could buffer 4 key presses. So normally it sits there with, the read and the write, the 2 pointers on kind of the head and the tail kind of pointing to the same spot in your little cue. But as soon as you push a key, and it matches the current 256, the 8-bit counter, it will increment the head pointer on that cue and push something into that register file. Now, as soon as the head and the tail pointers in that register file are not equal, there's actually some XOR gates in here that do that. It will read from the register file, and then it will output to the punch. So you got the whole thing coming on with the register file, and you got the free running counter. I kind of understand that, but it's kind of inconvenient for me to figure out how to program to it, because I just wanted to be able just to shove some signals on here, but I really can't, because this thing is just spewing a counter onto there in normal circumstance until you push a key. There's also a 256x4 shift register. I have no idea why that's in there. I did not get far enough to evaluate that. It's just like strange. Why do we need that of all things? There's no CPU anywhere. There's a connector here for a display panel, connector for a VDU. Nothing ever plugged into the VDU. I'm guessing VDU is like video display unit maybe. It has something that hooks up to the various outputs kind of in parallel with the ones that go to the punch. So maybe as you were typing, something could, show what keys you'd pushed, and this would be like a feedback for the operator. I'm not sure. Fantastically complex keyboard interface. Like I said, it seems to be sending out this 8-bit counter, and then maybe something comes back to tell it to push a key. But there's also like 15 other lines doing weird stuff to that keyboard. I have no idea. Didn't go that far with it to try to figure it out. But anyway, my goal with this is to be able to control the punch with a Raspberry Pi. So what I am going to do is I'm going to intercept the 2 register files. There's a read enable bit, which is always grounded, which is why these things are constantly spewing data out into this resistor and going into there. So I'm going to come up with a way to disable that so these things stop spewing out nonsense. Then I will grab the 6 bits on here and drive them from the Raspberry Pi to output which character I want. And then I think I'm going to go into the keyboard, and I'm just going to hook a relay up to the tape forward button And my assumption is that when I push tape forward, whatever's in here will get sent out there to the punch. Now there's one other thing I wanted to mention in this that I figured out, and that is this 555 timer up here. This, I reverse engineered it, looked it up in a cookbook of 555 timers, and found the closest thing described as a sine wave to square wave converter. So it is taking the signal from the punch that goes around every time the punch goes around. It's generating some kind of like a sine wave. It's because what we're going to do, and the way this whole thing works, is you pull in the solenoids that you want at the right cycle on that revolution, and then the motor that's spinning around in that punch, those solenoids are pulled out, it will come and it will hit those and do the punch, and then release them. So the motor kind of spins continuously. Occasionally, when these solenoids are engaged, it will grab one of those punches, it'll punch the chunk out of the paper. So this is, this is a very industrial, serious mechanism. It's not like a hobbyist quality or low duty paper punch. Okay, so I've made my changes. So first of all, I took and I pulled that resistor pack here that was the pull-ups, and I put a wire wrap socket in and a little piece of proto board and some headers. So I now have access to all of the pins on that pull-up resistor. I can put headers in going to my microcontroller. The other thing I did is this green terminal is now hooked up to the read strobes on the two 4x4 register files. And if you look at the bottom, you can see that I disconnected those pins from ground. I did a little bit of surgery to rewire ground to it. And then I also added right there a pull down resistor so that if we're not controlling it with the microcontroller, then it automatically pulls down, reverts to the previous behavior. I've also added lots of test points around, so some of these black ones are grounds that'll be handy to pick up. There's a red one that's 5 volt, and then a few of the ones were test points that the board came with. So right now it's ready to reinstall, and I'm going to try to figure out how to hook up Raspberry Pi or something to it. Okay, we are ready to do a demo. So haphazardly balanced in here is a bunch of stuff. Right here, this thing here is a board that I put together to control the typesetter from the Raspberry Pi. Now it has a GAL22V10 programmable logic device. I've started doing that with a lot of my projects. Better to implement hardware in software, that way it's easier to change things around. Basically it implements the equivalent of some open collector outputs and some AND gates. But into it we have 8 lines where the Raspberry Pi tells it which of the 8 holes it wants punched out. And then 1 line that says to take over, so to take over so the typesetter's keyboard is no longer running things, but the Raspberry Pi will be running it. And then another line that says advance 1 spot on the tape. So what we will do is we assert the takeover signal, and then we put out the data bits that we want for the 8 punches, and then we do the advance 1 position, and we'll just keep hammering that out until it prints all the holes. Now over here we have the lines that go out to the typesetter. So there's 6 of them for the typesetter's 6 punches that it knows how to do. There's ones that hook up to the key, so up to the tape feed key, both sides of it, so that we can sense when it's being pulled and we can output the pulling. We've got a wire here that implements the takeover feature, a ground, and then we have stuff to hook up the remaining 2 bits. So as I mentioned already in the video, this typesetter was only a 6-bit device. It output 6 bits on the paper. But the paper punch mechanism has all 8 bits. So what I did, as you can see here under my my thumb, is there's a couple MOSFETs here. I think I used, what I did is I put a couple of MTP 3055 MOSFETs. Those should be capable of driving those hammers in the punch. And I interfaced them to my PLD, so it tells when it wants those 2 bits punched. And it also has some lines here that come out that go into the logic board that tell this device when it's ready to be punched. So you can't just punch the hammers at any old time. You got to wait until the cycle is in the right spot. So basically it synchronizes the 2 additional punch bits to the 6 that the device already supported. So okay, we will drag this all out to a safe spot. We will fire it up and we'll do our demo. Okay, the Raspberry Pi program is currently running. I've got the power to the typesetter itself is off, But the Pi program is running and it's outputting the signals right now to control the components inside the typesetter. So as soon as I turn the typesetter on, we will get my test pattern here on the tape that is coming off the Raspberry Pi program. And the test pattern is simply to, light up the individual punches, one after another, all 8 of them. So let's turn it on. And there it goes. Now, a real computer punch would probably run faster than this. We have to keep in mind this thing was designed for humans to use. It was designed for people to be typing, so there's probably some limits in it as to just how fast the logic board works. I think the punch mechanism itself could go pretty quick, but the limiting factor is probably the logic board. Okay, here's a view of the backside of the project. So you can see I ended up going with Raspberry Pi 0W. It's mounted right here. Connectors come over to this board, which is my breakout board, which has the MOSFETs and the PLD and stuff, which handles the logic for driving the main board, which is down in here. Okay, one more quick demo. One thing that was popular back in the 70s with these paper tape things was to print letters out on them. So this 8 dots wide, so we can easily use an 8x8 font and print it on there. So I wrote a Raspberry Pi program that will do that. So let me run it and we'll print out a message on the... Alright, simple as that. Okay, I hope you enjoyed this video. We'll call this one part 1 because I'm going to come back with part 2 and there's a couple next steps to take. So for one, I need to add like a DB9 or DB25 serial port so that I can hook this up to my vintage computers, my RC2014, my H8, etc. So we need to actually hook this to the vintage computer. I may or may not leave the Raspberry Pi in it. I could replace the Raspberry Pi with an Arduino, be something, a little bit more lightweight. Maybe I'll leave the Pi in. It's nice to have Wi-Fi and stuff. But anyway, get this hooked up to the vintage computer is the next task. And then after that, I need to come up with a reader because it's great to be able to write these things. And I'm pretty sure in, like an afternoon, I could finish this up to the point where it's hooked up to the H8 and I could hit save and, a program would spew out on here. But it's no good if I don't have anything to read it. So I'll either DIY a reader, or I'll buy something like a Remex CNC reader or something designed to read paper tapes. You can pick those up relatively cheaply. We will see where it takes us, so stay tuned for part 2 in the near future. Thank you for watching my video. Please visit my website at www.smbaker.com for more electronics projects and sandrail stuff. Bye.